Hello everyone, I am Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. In our last lesson, we talked about the rule for differentiation. In today's lesson, we'll be talking about how to calculate the equation of tangents and normals. All right, so tangents and normals. All right, as you can see on the diagram, I've got a diagram, a diagram that has got some lines there. So we are going to define the tangent and normal using this diagram here. So actually the tangent and normals are straight lines, right? So from our previous lesson, we said tangent is a straight line that passes through a point on a curve, right? So if you're going to consider the second line that I've drawn here, it is called the normal because it is a line that passes through the same point of tangency, but it is perpendicular to this tangent here. All right, so again, normal is a straight line, a tangent is a straight line. So we learned how to calculate the equation of tangents and normals. All right, firstly, from our previous knowledge, grade 11 topic, we have learned that the gradient of two perpendicular lines will be of this form. The relationship between the gradient of two perpendicular lines. Gradient 1 multiplied by gradient 2 will give us a negative 1. All right, so we're going to use this relationship to calculate the gradient of this normal in order to calculate the equation. All right, so let's look at one example. If I have a function f of x equals, say, 2x squared plus 3x plus 5, and I ask you to work out the equation of the tangent and normal through these points. Let's say points, or one point, that is 2 and 19. Right, the first thing that we need to do is to work out the gradient function of the given curve. So the gradient function, we know from the rule for differentiation, is given by f prime x, or you can say dy over dx, is equal to, by applying the rule for differentiation, bring the 2 in front, and multiply by 2, you get 4x, and we subtract 1 from this, and it will be just 4x raised to the power of 1. Plus, differentiating this, we'll get 3, because 1 brought in front, multiplied by 3 gives us 3. Subtract 1, take a 1, it gives us 0. X raised to the power of 0 is basically 1, so 1 times 3 is 3. The constant derivative of the constant is 0. Right, so let's work out the gradient of this curve at point 29. The gradient of, again, the function at this point is going to be using this gradient function. We will have f prime 2 is equal to 4 multiplied by 2 plus 3. 4 by 2 is 8. 8 plus 3 is 11. Right. Therefore, we are going to conclude and say m1, the gradient m1 is equal to 11 is the gradient of this tangent line. Okay, from our previous knowledge, our lessons, we said the gradient that you calculate at a point, a certain point, is the gradient of the tangent line. Right, so how do we calculate, given the gradient of this tangent, how do we calculate the equation of this tangent? Okay, from our knowledge from grade 11 in coordinate geometry, we learned that if given 1 point and a gradient, then we can use this formula. Y minus y1 is equal to m times x minus x1. We take the point given and the gradient substitute to calculate the equation of the tangent. So y minus 19. 19 is the y coordinate of the point. Gradient is 11. X minus the y coordinate of the point is 2. So we can expand the right-hand side. That's 11x minus 22, and this side is y minus 19. Right, so taking the 19 over, which is negative 19 over to the side, it becomes positive. So the equation now becomes 11x minus 3. Right, so what is this equation? It is an equation of a straight line in gradient-intercept form. Right, so, and is actually the equation of the tangent that we have calculated. Right. Now let's look at how to determine the gradient of a normal line. Again, the normal is a line that is perpendicular to the tangent. And the relationship will be, as we have seen, m1 times m2 gives us a negative 1. So substituting in that formula, gradient 11, we will have m2 multiplied by 11 will be equal to negative 1. Therefore, m2 is equal to, we divide both sides by 11, we get negative, negative 1 over 11. I think we can write that. Now this is the gradient of the normal line, right? So after determining the gradient of the normal line, we can now use the same formula and use the same point because it will be passing through the same point 219. Therefore, by using the same formula, we will say y minus 19 is equal to the gradient. This time is not 11, but negative 1 over 11 multiplied by x minus 2. Right, so expanding this, we will have the right side. We will get y minus 19 is equal to negative x over 11. A negative times a negative gives us a positive 2 over 11. And the next part is for us to bring the negative 19 over to the other side, or adding negative 19 on both sides, we will have y is equal to minus x over 11 plus 2 over 11 plus 19. Right, so the rest is evaluating this part, and that becomes the equation of our normal. So minus x over 11 plus the LCD here is 11. So we write 11 into 11 is 1. 1 times 2 is 2 plus 1 divide is 1. 1 divide 11 is 11. 11 multiplied by 19 will be around 209. Right, so y therefore is equal to negative x over 11 plus 2 plus 209 will be 211 over 11. Right, so what is this equation? It's an equation of a straight line, and that represents the equation of the normal. Right, so in this lesson, what we have learned is using the ideas of calculus, we have applied it to calculate the equation of the tangent, a line that passes through a point on a curve, and also a line that is perpendicular to the tangent, which is called a normal, to calculate the equation of both straight lines. So thank you. That's the end of our lesson. And in our next lesson, we'll talk about determining the nature of the turning points. Thank you.